So let's go to a problem. We know that the standard basis so these are like ijk vectors, the unit vectors. So these are the standard basis for R cube. Like for any R cube, these are the like standard basis. And but these are not the only basis we have. Like we can develop another basis as well, which means like other than having the axis as x and y, x, y and z, we can get another axis. So from that we can develop the R cube vector space. So that's what we are going to do here. We are given to prove that these three v1, v2, v3 are basis of R cube. So first we need to prove that these three should span R cube, like which means so should spanning, and the second one is linear independent. So let's show the first one. So we have so to prove that it's a spanning, like let's say any vector in V as a1, a2, a3. So this is any vector in R cube. So spanning means like we need to have k1 v1 plus k2 v2 plus k3 v3 equals v, which means a1, a2, a3. This should be true for all for all a1, a2, a3. There should be constants k1, k2, k3, which means this equation should be this. If we transform this into a matrix equation, linear matrix equation, the matrix should be consistent for all values of a1, a2, a3. Let's build up that linear equation. So if we substitute v1, v2 and v3, we will end up with k1 into a1 equals k1 plus 2k2 plus 3k3, and a2 equals 2k1 plus 9k2 plus 3k3, and a3 equals k1 plus 4k3. So we can like transform this into matrix equations. So when we transform this, we have 1, 2, 3, 2, 9, 3, 1, 0, 4 into k1, k2, k3 equals a1, a2, a3. So to solve this equation, like to get a proper solution, we need to transform this into, like do row operations on this matrix and get the row echelon form of this matrix to get a better understanding of the equations. Let's do that. We have 1, 2, 3, and if we multiply this by 2 and subtract from the second row, we get 0. So we transform this matrix A into row echelon format and get the final row echelon format as this. From this we can find, like whatever the operation we do here, there will be like some constants corresponding to these rows, which means like we can find k1, k2, k3 such that to satisfy these equations, which means like this has a consistent solution for all a1, a2, a3, which means like for all a1, a2, a3 we have k1, k2, k3 to solve, like whatever a1, a2, a3 you put. And at the same time, there's an easy way to solve this. Like what we need to show is this equation, ax equal to b. In this matrix equation, we need to show that this has a consistent solution. So since this is not a trivial one, like this is not a 0 0 0 for all a1 a2 a3, if we be able to solve that determinant of a is not equal to 0, this will give a consistent solution from our semester 1 knowledge. So since determinant of a is -1, which is not equal to 0, we can obviously say that this has a consistent solution, which means this set, like this vector set of these three vectors spans R cube. That's one first step we need to show. And the other step is the linear independent. Like we need to show that these three vectors are linear independent vectors. So according to the theorem we studied, so we need to show that k1 v1 plus k2 v2 plus k3 v3 equal to 0 has only trivial solution. So the same equation will come, like the same equation will be for us, like ax equal to b, which means 1 2 3 2 9 3 1 0 4. This equation. So what we need to prove is we need to have only consistent, only trivial solution for this. Since the determinant of a is not equal to 0, as we shown, like that's -1, from the semester 1 knowledge we have, if there is a matrix equation in the format ax equal to 0 and the determinant of a equal to not equal to 0, we can show that this equation only has the trivial solution. If det a not equal to 0, it has only trivial solution. So from this we can have the only solution for this equation is k1 equal to 0, k2 equal to 0, k3 equal to 0. So that implies v1, v2, v3 are linearly independent. So these three vectors are linearly independent and these three vectors span R cube. So we can show that these three are one of the bases, like these three are bases of R cube.